Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, paper 5. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 20 says, a 150 grams mass was hung from a spring as shown in the figure. The spring extended by 7.5 centimeters. The mass was displaced vertically 3.0 centimeters from its equilibrium position, then released. The mass oscillated vertically. Explain why the motion of the mass was simple harmonic motion. For simple harmonic motion, there are two conditions you need to understand. Spring force is directly proportional to the displacement. When the displacement is maximum, spring force will be maximum. When the displacement is minimum, spring force will be minimum. And direction of force and displacement, they are in opposite directions. So what exactly I'm saying is that for SHM, you need to understand these conditions. Acceleration is directly proportional to displacement, but here we have also negative sign. It means that acceleration and displacement are directly proportional, but they are in opposite directions. When acceleration is positive, displacement is negative. When displacement is negative, acceleration is positive. And acceleration and force, they are always in same direction. So we can say force and displacement, they are directly proportional, but they are in opposite directions. And this is true for this system as well. So that's the reason the motion of this one is simple harmonic motion. So these points you have to write down in the answer. And this question has 2 marks. So 2 points you can write down. So the first point you can say force is directly proportional to displacement, as force is depending on displacement. Force and displacement, they are in opposite directions. Now let me show you the answer, how you can write down your answer. Restoring force, you can say point 1 proportional to displacement. Second, you can say direction of the force. Force always acts towards equilibrium. It also means that force is in opposite direction of displacement. So when the mass is here, for example, mass is here, so the displacement in this case, we can take displacement is negative because this is downwards, we are taking up is positive. But force, spring force on this one will be in upward direction. The mass is here at this point. Force will be downward, means force is always towards equilibrium. These 2 points you have to mention in the answer. So if you have written, you will get 2 marks. Part B says calculate the maximum velocity of the oscillating mass. But for this one, there are few points you need to understand how to answer this question, and also those are very important concepts. So first of all, we need to calculate Vmax, and Vmax simply is equal to amplitude, means the maximum displacement, times angular frequency, omega. But how we can find out value of A? Value of A is already actually given to us. So let's try to understand this one step by step. So first of all, in the question it was given to us, we have the spring. And then we attach mass with this spring. So when we attach mass, this spring extended by, so this extension is given in the last part. This is equal to 7.5 centimeters. So at this point, mg is acting down. Mg is down and spring is in equilibrium at this point. So the spring force is equal to mg. But then we extend this one further down. So let me draw here. So we extend this one further down. It is here. So from here actually, this one we can say this displacement is 3.0 centimeters and this is the amplitude. Now with this one it will start oscillating. So this is 3.0 centimeters down, then it will go up. by 3.0 centimeters. So it will be oscillating with amplitude of 3.0 centimeters. So this is the main story. These are the concepts you need to understand. Now how we can find out value of K? So to find value of K when it is in equilibrium at this point, so we can simply say mg, this one has to be equal to the spring force kx. So we can say K from here will be equal to mg divided by x. So value of mg we will plug in, value of x is this one, and we can find out value of K. And when we have value of K, then we need to find out omega. So you can find omega by two different ways. So first thing you need to understand, time period of spring mass system is equal to 2 pi m over K. If you compare, T is also equal to 2 pi over omega. So if you compare these two, we will get omega is equal to K over m, Q over m. So this is the omega. So we can get value of K from here, value of m already we have, so we can find omega. Or simply we can say omega square will be equal to K over m. So if we have value of K from here, means we will calculate from here. Mass attached with this spring is already given to us. That was equal to 150 grams, and we can find out value of omega. Then we can plug in here and we can find the V max. Or you can directly use this one. You can use this, and you can also try to find out value of omega from here. You can also try to find, but this is a smart way to answer. So omega you can find out from here. Omega is equal to K over m. So if you use this one, you will find time period first of all. If you use this formula, then you will find frequency. Then frequency you will say is equal to 2 pi f. Omega is equal to 2 pi f. So from f you will be able to find omega. So that will be a little bit long. If you have this understanding, you can plug in values, you can find the answer. I hope this gives you the main idea how to answer the question. Now let's go through the solution I have written. So we can go through the solution, how to find the answer. So simply as I explained you, first of all we have found the value of K. Then we have find value of omega. I have explained why omega is equal to square root of K over m. So you will get the value of omega. Then V max is equal to omega times A, and this is our final answer up to 2SF. This is the final answer. So this is how you need to approach. Part C says explain why the maximum velocity of the oscillating mass decreased over time. Velocity will decrease. There are two main reasons. One is due to air resistance. So due to air resistance, the system will be losing energy. It means the mechanical energy of the system will be converted into thermal energy. And also due to internal friction, mechanical energy will be converted into thermal energy. So the system will be losing mechanical energy. It means kinetic energy will be decreasing. So the maximum velocity will be decreasing. So these are the points you need to understand. Now let me show you the answer. So in the answer, you can write down these points. So first point, you can say the system loses energy due to air resistance and internal friction. As energy is dissipated, so amplitude decreases, and of course velocity will also decrease. So this is how you can answer. Question 21 says during their life cycle, stars go through a number of stages. Betelgeuse is a red giant star with a luminosity of 4.49 times 10 to 31 watts. The peak intensity of radiation from Betelgeuse occurs at a wavelength of 850 nanometers. A website claims that the radius of Betelgeuse is 1000 times the radius of the Sun. Assess the accuracy of this claim. So surface temperature of the Sun is given to us, luminosity of the Sun is also given to us. So for this question we have to compare the radius, and for that one we need Stephen-Boltzmann law. Means the luminosity, this is equal to sigma A T to the power of 4. So radius is involved, so you have to use Stephen-Boltzmann law. And here in this case, the area of the star, surface area of the star, this is 4 pi r square times t to the power of 4. So r is the radius of the star. Now for Betelgeuse, we don't have its radius, we don't have its temperature. So first of all, we need to calculate its temperature because we have the wavelength of peak intensity. So we can use Wien's displacement law. So first of all, we can use Wien's displacement law. We can say lambda max times t, this is equal to constant. So this is equal to constant, and the value of this one is about 2.8 times 10 to minus 3 meter Kelvin. So this is the value of the constant, approximate. Now from here we can find out temperature in Kelvin. So we can find out temperature in Kelvin. So if we have this temperature, so we can use here. But if you look at this formula, in this formula you can see luminosity over r square divided by t to the power of 4. This is equal to sigma times 4 pi, and this is constant. This is constant for any star. So this is constant for Betelgeuse, it is also constant for Sun. So simply in this case we can say L of Sun divided by the R for the Sun. So I'll be using letter S, and surface temperature of the Sun, this has to be equal to luminosity of Betelgeuse, I'll be using P sub P, and this is radius of Betelgeuse square, and surface temperature of Betelgeuse t to the power of 4. So we need to find out the ratio between RB and RS. So we can write on from here that luminosity of the Sun times RB square times TB to the power of 4. This has to be equal to LB RS square and TS to the power of 4. So we can say from here RB over RS square. So we have the square here. This has to be equal to LB TS to the power of 4 divided by, this has to be luminosity of the Sun times T temperature, surface temperature of Betelgeuse to the power of 4. So from here we can find out. Now if we take square root on both sides, square root on both sides, so simply we can take square root of this one and we can find the ratio. If this ratio is close to 1000, it means statement is valid. If not, statement is not valid. Now simply we need to plug in values. So the luminosity of Betelgeuse, we have, this is luminosity. We have surface temperature, we have found surface temperature of the Sun. So this is surface temperature of the Sun. So we can plug in here. Luminosity of the Sun, we have, this is, we can plug in here. And temperature of Betelgeuse we have found from here. Now simply plug in and find the answer. So this is how you need to approach the problem. I hope this makes sense to you. Now let me show you the answer with numbers, how you need to calculate. So here this is how you need to calculate if you plug in numbers. So this is how you will get the final answer. So we have calculated, first of all, this is Wien's displacement law we are using. We have got surface temperature of Betelgeuse, then we are using Stephen-Boltzmann law. So this is Stephen-Boltzmann law as we have discussed before. Then we are using the ratio. So in this case answer is about 990. As this value is close to 1000, so it means the statement is valid. So this is how we can. And second part says the HR diagram shows the positions of some main sequence stars. Add the approximate position of the Sun and Betelgeuse to the diagram. Mark the positions with labeled crosses. So in this case, first thing we need to understand is that the luminosity of the Sun as a reference we take is equal to 1. So it means Sun luminosity here. So this is luminosity of the Sun. we take this one as a reference. This is equal to 1. So it means sun must be located here. So sun can be in this region. So sun can be located here. So this is, we can say this one is sun. So sun can be located here. And for the Betelgeuse, the luminosity of the Betelgeuse, we have this one. And luminosity of the sun is about equal to 3.8 times 10 to 26. So this is 31. So it's about 10 to 5 times greater than intensity of the sun. And the surface temperature of Betelgeuse we have found that was about 3400 Kelvin. So luminosity should be about 10 to 4. So it means it can be located here, 10 to 4, more than 10 to 4. So it can be here. It can be here in this region. In this region. And the temperature, this is 2500. So temperature is 3400. So Betelgeuse can be located in this region. So this one is Betelgeuse. So we have to write down the name of the Betelgeuse. So I'm just writing P here. This is for Betelgeuse. So this is how you can answer. So what, and this is a red giant, so it has to be away from the main sequence. You can also compare the luminosity, as this is luminosity of Betelgeuse, this is luminosity of the sun, and luminosity of the sun on HR diagram, we take 1 as a reference. And then we can compare the luminosity of other stars with the luminosity of sun. And surface temperature we have also calculated, so you can see from here, this is 2500, so temperature has to be greater, so it has to be on the left side. Now let's go to next part. Question is asking us, state what is meant by a main sequence star. So main sequence stars means when the star is at the main sequence, star is stable. And when the stars are stable, they are fusing hydrogen into helium. So these points you have to write down. If you write down, you will get 1 mark. So now let me show you the answer. So this is for our previous question, and this is for the next one. So this is, so you can see the exact positions on this one. And this answer you can see now, main sequence you can say, fusing hydrogen into helium, maintaining a stable equilibrium between gravitational attraction, means contraction, and thermal expansion. And this is the longest stage in star's life cycle. So these points you need to understand about main sequence star. Part B says the final stage of evolution for a massive star may be a rotating neutron star. One neutron star rotates with a period of 33.5 milliseconds. As the star rotates, one side of the star moves towards Earth while the other side of the star moves away from Earth. This causes a range of wavelengths to be received by an observer on our planet. Ultraviolet radiation of wavelengths 91.2 nanometer is emitted by the star. This radiation is emitted by the star, but for the observer, the observed wavelength, that will be different. Calculate the maximum and minimum wavelengths observed. One side of the star is approaching, so maximum wavelength, the other is moving away, so they will be, star is approaching, so that wavelength will be small, star is moving away, that wavelength will be longer. So we need to find out those two values. Diameter of the star is given to us. So we need to find out lambda max. So lambda max will be equal to the lambda emitted. So let's try to understand the main concept. Plus redshift means the Doppler shift. So this one is Doppler shift, delta lambda. And how about lambda minimum? Lambda minimum will be equal to the lambda emitted minus delta lambda. So this is the blue shift and this is red shift. So how we can find out delta lambda? Because lambda emitted we have, so how we can find out delta lambda? To find delta lambda, we need to understand Doppler shift equation. That is delta lambda over lambda is equal to V over C, and this is lambda emitted. So lambda emitted we have C, this is a constant. So if we have V, actually we can find out delta lambda. So how we can find the V? So this one is the star, so this is star, and this star has certain angular velocity, and the velocity, tangential velocity, is maximum at this point when it is moving towards or moving away. So the V at this point is maximum. So we need to find out this value of V, and that will be equal to R times omega. We have diameter of the star, so we can find the radius from here. We can find value of R. So we need to find omega now. How we can find omega? Omega will be equal to 2 pi divided by the time period of the star. So here we have time period of the star. So we can find value of V, and we can plug in value of V here, and then we can find out delta lambda, and then we can find lambda max, we can find lambda minimum. So this is how you need to approach. I hope this makes sense to you now. Now let me show you the answer with numbers. Let's go to the solution. So always organize your thoughts. First of all, what is the main thing you need to calculate? Start from that, then go backward. What is given to you and what you need. Then you need to figure out how you can find the value of the unknown quantity. So if you look at this answer now, you can see I have written this one. So first of all, what I have done is I have calculated omega. So this is value of omega, and then we have found V max, then we have found delta lambda by lambda, and then from here we have delta lambda. So this is Doppler shift. So this is value of Doppler shift, means the change in the wavelength we have calculated. So then we have added, so this is red shift, and this is blue shift, and this is the answer. So this is how you can approach this question. I hope this makes sense to you. This is very nice question because it involves more than one steps. So multi-step questions are very important to practice. If you want to improve your understanding of physics, so do multi-step question. One-step questions are easy questions. Multi-step questions help you to organize your thoughts, and they help you to develop your understanding. And that's all for this video. We have done this whole paper. So if you have any questions or any doubts, please leave your questions in comments, and I will try to answer as soon as possible. And if these videos are helping you to improve your understanding of physics, please like and subscribe, and also share with your friends. And if you're looking for extra resources, you can also join Patreon. On Patreon, you will see a lot of resources. See you in next video. And all the best for your coming exam.